And welcome to NTWC Live. Tim is off this week. He's out on a much-needed vacation doing a lot of interesting things. We have some great guests today. We have Dan Harkings and Carrie Emanuel. And, we've got a really good topic as well. Talking about satellites, talking about things that are new that are coming up in hurricane forecasting. First, we do want to let our folks know that, yes, we're on a podcast as well. It's called Hurricane Center Podcast. You can pick that up on Apple Podcasts or your favorite podcast app. And we'd like to thank also our friends over at USAA, also South Padre Island Convention and Tourist Bureau. Those are the two guys, or the two groups that really help fund this activity that we do every year, which is called the National Tropical Weather Conference. And, of course, this livecast podcast. Would also like to thank the people over at Weather Company, Weather Boy, and Weather Call. And this morning, let's see if we can start off with Bill Reed. Bill, how are you doing this morning?
Okay, we've got the Saharan dust in here and near record mold spores. So for the first time in a decade, I've got an allergy issue going on. So if I start sneezing and hacking, that's what it is. No big deal.
All right, Hal, what's going on for you this morning?
Good morning, Alex. I'm Hal Needham down in Galveston Island. If my camera fogs up, we're experiencing the highest dew points I've ever seen. We had 20 hours at 82. And 2 hours in the last 3 days, we're at an 83-degree dew point. It's those 13 days of continuous rain after Hurricane Beryl. Everything is swamped, and it's very, very humid down here on the Texas coast. Yeah, for sure. So excited to have Daniel Harkins on NTWC Plus today. He has held senior level positions as marketing manager or sales manager for the past 20 years across several industries, including satellite, digital manufacturing, life sciences, and biophysics instrumentation. As the co-inventor and author of the first instrument to measure gene expression in intact tissue, Daniel has helped bring over 10 products to market that have generated over $300 million in sales through comprehensive digital, direct, and go-to-market strategies. Dan, so great to have you on NTWC Plus this morning.
Hey, thanks so much for having me, and good morning to everybody.
Morning.
Daniel, I'm sorry, go ahead. Daniel, you've done so much just in many different fields, related to different kinds of technologies. We're excited to have you on the show this morning and hear how all of this plays out with emerging technologies. And it sounds like you've worked in satellite data and innovation for quite some time.
Yeah, I've been in the satellite industry for about 7 years now. It really flows through what I used to do, working with instrumentation that measured photosynthetic activity. And this really had a broad impact on climate change and how to deal with it. So this could be from coral reefs, which are photosynthetically active, and obviously a big major part of what's happening with warming oceans, as well as agriculture. So these measurements worked on agriculture too. So it was really a natural progression that eventually I got into satellites and trying to fight climate change from space. And I joined this team a little bit about 4 years ago, and I was really interested by the technology as hurricanes are will become more intense and frequent and harder to predict as the oceans warm. So I really love this technology. It was something a little bit different than what I'd seen out there because it's not radar-based, it's not really sensor-based. They'd already had 5 years to prove and validate the technology on the International Space Station. So I felt like it was really a good time to, find a way to help these guys introduce this new tool that will provide earlier and more accurate hurricane forecasts. Come to find out, we also collect global 3D wind data that I didn't know was going to be really important at that time. And the importance of cloud coverage at our scale and revisit rate will also be a pretty big deal because these are 3D clouds and we're assigning them to altitudes at 100-meter scale. So the impact that we will have, not just on weather and the weather that people rely on, when they look up, they get up in the morning, they look at their phone, what's the weather going to be? We can, potentially our data will make that more accurate. And so the applications for that are beyond, certainly want to save lives, but also there is economic pressure always on any business to make money off of weather somehow, some way. And so we're trying to push the humanitarian and commercialization project as far ahead as we can. The exciting part is that our first 2 Hurricane Hunter weather satellites are in production. And we're going to launch in Q1 of 2026. Our partner, Phantom Space Corp, former SpaceX guy, started that. They are a rocket launch and satellite manufacturer, as well as operator. So we will just get that data, hand it off to meteorologists, and they'll be able to integrate that into their models and spit out better forecasts.
Dan, what do you feel are the most impactful innovations that have emerged in the last several years for improving tropical weather prediction?
I think overall the satellite capabilities and the observation capability. I don't want to go into too many, but even a company like Spire or Planet, and obviously the GOES are the most important. And having those up, that might be the one that impacts us the most. Actually, is the GOES. Our satellite buses initially started out over 10 years ago as 2 very large satellites, about 2,000 kilograms. And right now they're 12U CubeSats, and that's because the GOES gets a temperature measurement that we can now get, so we don't have to build that payload anymore. So the GOES is by far maybe our greatest tool that we have for tropical weather, as well as just general weather.
Dan, you mentioned the emerging technology with 3D imaging of storms and cloud coverage. I mean, how does that help tropical weather prediction as well?
Well, getting the cloud top heights at 100-meter scale will be a game changer for sure, as well as getting the vertical and horizontal wind. So how we measure and the algorithms that we use is we use 2 different satellites, getting stereoscopic imagery from the cloud, basically, or the tropical cyclone. And from there, that not only do we get a nice, pretty picture of a 3D image of the storm, which can be really helpful, especially for looking at the eye wall structure, but also we get numerical data from that's spit out in the 3D wind, as well as seeing the steering wind environment. So because we're taking
I think we have some background noise here. I'm sorry, Dan. I think Dan, I think we can continue now. Thank you.
Okay. Yeah. So the steering wind environment is also going to be a big game changer for us and how we can help improve the forecast, because we are taking swaths as we pass over about 3,000 by 3,000 kilometers. So we'll be able to look at not just the storm, but the steering wind environment as well.
Dan, the 3D imaging, is that polar orbiting satellites? Can you zoom in a bit on geostationary? I mean, how are you actually getting those, and what does the temporal resolution look like on those?
So we will be in LEO, so only about 500 kilometers around the Earth. And when the full constellation is deployed, so the first 2 are going up, there are 8 more planned for that. And we're expecting a revisit rate of about every 2.5 hours from the first 10. Which is not bad. The generation 2, we've worked out what we're going to use for payloads. So right now we can't do clear air. So the generation 2 will have hyperspec, so we can get real, true global 3D wind measurements. Right now we can only do daytime and when there are clouds, but thankfully, Earth is covered by clouds about 67% at any given time. So there's plenty of clouds out there for us to measure.
Well, thanks, Dan. Bill, you always have insightful questions about emerging technologies. Any questions here on satellites for Dan?
I probably got a million, but I'll condense it into something smaller than that. I was fascinated that you were able to test out some of your ideas on the International Space Station. How did that come about?
Well, we worked hand in hand with NASA and DoD for some years prior. This was originally something called Project Ramos. This was going to be a joint mission between the U.S. and Russia, where we would build one satellite, they would build the other satellite. They would operate like our 2 eyes. And this was done to improve our relationship with the country, frankly. And so that's why DoD was shepherding it through for some time. And then we just got along so well that there was no need for the project, and we never had any problems with them again. So it was great. But in all seriousness, because of politics and a run-in with Putin, that was canceled, and NASA and DoD still wanted to continue the work. Well, maybe the satellites not yet, but how do we still develop this technology because we're so far along? And so from there was maybe about 3 more years or so of us developing the algorithms, and the how we take the images is a big part of the technology, because the space station and even CubeSats, they're moving really fast. And so we're trying to get image acquisition from a moving platform, and then we're getting it too at the same time, right, from different angles, and then we got to put those together. So from there, once we developed that to a point, NASA was very keen to see if this would work. And so they were instrumental in helping us get onto the space station. And that was the CIMUS mission, which was the Tropical Cyclone Intensity from the ISS. So that's what CIMUS stands for. And that took us about 5 years. The astronauts carried out the image acquisition based on the protocols that our scientists on the ground set. And then working with the other scientists from NASA and NOAA, I believe, we would kind of, our scientists would apply the algorithms, and then they would really integrate them into their models to see if, okay, is this working? And then so that whole mission was about 5 years. But about 3 years was a run-up from the cancellation of the original satellite project to still developing technology and then testing it.
Cool. For confirming your information on that, do you try to target storms that are being flown by the hurricane hunters in their aircraft, or how do you ground truth what it is you're getting from the satellite?
Yeah, well, that's what we'll be really excited about moving forward. I wasn't there at the time, but I'm fairly sure that there was some correspondence between the two. These do not replace Hurricane Hunter satellites. They're like in addition to. However, countries that do not have, Hurricane Hunter aircraft, countries that do not have Hurricane Hunter aircraft, this is a good substitute and a very economic one. It cost us about $250 million a year, I think, to run that fleet. So most countries really can't afford that, and we can do it for, $10 million a year or so. We can give you, hurricane forecast at similar level. So what we're really excited about is at a certain point, we will be able to look at their data, compare it against ours. In some way, there's going to be an integration because they can't fly all the time. So there are mechanical issues. They can only, fly through the storm so many times during the storm. They can't revisit every 2.5 hours like we can. Someday, when Generation 2 is up, we're hoping that's a 15 minutes from image acquisition to in the user's hands. And we do have the technology for that. We know that's possible. It's just a matter of getting the number of satellites up there. So we do feel like they'll be able to improve what we do for forecasting, and that our data will help them improve what they do.
Yeah, I mean, we sometimes have to argue with Congress to keep our fleet of recon planes. So I know other countries are challenged financially to look at it.
Yeah, it's crazy to think about the cost of prevention and the cost of forecasting, and that we are just so almost programmed in a way to try to save a couple of nickels and then wait for the event to happen, and then the cleanup and disaster relief is so much more. I really feel like somehow we've got to do better, all of us on the meteorology side, maybe of messaging, because it's a little crazy that at this time in this place, that even considering that these things are on the chopping block, and what that would cause, cities would be wiped out if not for this kind of, the dedication of those crews that are brave enough to fly in there. That's not an easy thing, flying into a hurricane. We should be looking at how we could spend more on those aircraft in that fleet rather than reducing.
Yeah, one of the benefits I can see from your technology is one of the things that's critical in the short term as the storm's making landfall is getting the most up-to-date, refreshed data in the hands of the first responders, because they're the ones that are right after the storm hits, they're going to be going in doing perhaps life-saving activities, but certainly trying to get things back in gear. And the more we can isolate where that is as it comes up on landfall, the better off they'll be.
Yeah, absolutely. In any storm, 20 miles makes a difference. I know sometimes it's hard when you're looking at a map and you think, well, those are just right close to each other, right? But really having those assets and being aware of where they're going to hit. But not only that, I was talking about the mindset earlier of, why do we have this backwards mindset of funding prevention? But the way we message to people, are they, instead of this wide uncertainty, and sometimes that causes people to look at the hurricane 3-4 days beforehand and not think about they say it's going to hit Tampa, so I'm in Fort Myers and I'm going to be fine, and that turns out not to be the case sometimes, and we need people to look at it a little bit more, but then take it seriously. And the way we get people to take it more seriously is by improving the accuracy and the prediction, because then there's I think we cling to nobody wants to be disrupted by a hurricane, so they will believe they'll believe, lean on that side of we're a little bit outside, so maybe we don't have to evacuate, or maybe it's not going to hit us and the weather guy's wrong. The weather guy's always wrong, right? You always blame the weather guy. So we're hoping that improved predictions can change that mindset a little too.
Yeah, somehow you had to break the code on the denial. The natural tendency of denial. The smoker thinks he's not going to get cancer, for example. And in the hurricane thing, I think we're learning now that the spectrum of risk averseness really impacts how you message. It's not the same message that works well for someone that definitely doesn't want to go through a hurricane and they'll take the actions way in advance. Don't work very well with the folks that think even if it hits, it's not going to affect me kind of thinking. So yeah, that's an important point there. I was reading in your slide deck there about the ingesting the models. Are you all doing modeling yourself, or are you working in conjunction with other people to test the data in their models?
Yeah, so a couple of things on that is eventually we will have an internal team to do the modeling, but right now people have the computing power, the knowledge, and it's frankly something that we can go and get like a commodity, because there are a number of commercial weather companies out there that are already doing a pretty good job. So at the beginning, at the outset, we'll probably rely on 3 to 5 of these commercial companies to help us integrate and output the model, and they'll be doing the modeling, and obviously we'll work closely with NOAA and whoever else wants to integrate our data as well.
Very cool. Hal, you look like you got something on your mind there.
Yeah, Dan, just from a bird's eye view of tropical satellite monitoring, like how does this play out internationally? Is there a lot of collaboration? Does the US say, hey, Europe has this area covered, so we're going to focus somewhere else? Or is it kind of like every region for themselves? I mean, just from a bird's eye view, any generalizations you can share with us?
Unfortunately, I do feel like it's every region for themselves. I think Europe and the U.S. are working much better together and collaborating better. I know, way back when there was a little bit of rivalry between whose model's more accurate, who's not. I think we're a little past that, and it's just about improving. So I see that the collaboration there will continue, and I really hope that we bring in more so that it's a little bit more of a global thing. I know, in the past, the U.S. is pretty good about sharing their assets with other countries. So we're hoping that kind of continues, and that it's not, every man for himself, because it certainly sometimes feels that way in certain places.
Yeah, and Dan, when you mentioned the ISS, so was it I was interpreting like that astronauts on the ISS may actually do some customized imagery, like while they're passing over certain areas. Was that correct, or I don't know if I was interpreting that wrong.
Yes, indeed. The astronauts were very critical to the image acquisition protocol, and we do have some pictures from that mission of astronauts actually taking pictures at the time. So somebody took a picture of the astronaut taking a picture, which is fun. But yes, that was carried out by them, as well as cameras outside the ISS. So oddly enough, it was a lot harder for us to do it that way than it will be for us to do it with satellites, because that's pretty easy. We've got a star tracker that's extremely precise in both satellites, and the image acquisition is rolling pretty much.
Dan, do you know if the ISS has ever changed their track or orbit based on collecting imagery from a certain area for hurricanes or anything else? Or is that pretty much fixed and it's just they pass over where they pass over?
Interesting question. I really don't know that. I know for collision avoidance they change, but I'm not sure that they can change so much to track a particular storm. But I'm going to look into that because that's actually a really interesting topic.
Well, thanks, Dan. It was awesome to just hear these perspectives on satellite technology and all the research and things that you're involved with. Exciting stuff, and we're looking forward to hearing more from you through the broadcast today. I just appreciate you joining us here on National Tropical Weather Conference.
Yeah, thanks, and I appreciate it.
Bill, do we continue with your tropical weather forecast now, I believe?
Okay, I'll be
Right?
play weatherman here again. Guys are kind of let me do this once a week. Okay. Are you seeing a tropical weather outlook?
Yes, we
Yes,
sure are.
indeed.
Very good. A lot of chatter has been going on about a tropical wave that had a large circulation feature, but was engulfed in the Saharan air layer dust crossing the open Atlantic. It has now reached the northeast corner of the Caribbean, and as I'll show you in a minute, it's got some convective activity, but no sign of significant organization yet. NHC has outlooked a fairly broad area for potentially developing depression or storm on the weekend, probably anywhere from off the East Coast to maybe even the Eastern Gulf of Mexico. And we'll probably stay kind of sketchy like this until we have a defined center that we can actually home in on. The visual this morning, you can still see a lot of dust surrounding the system, but in the last 24 hours, a fairly concentrated area of showers and a few thunderstorms has developed in the wave, and fairly near where the lowest pressures and if a center were to develop would look to be. So that's somewhat ominous for those downstream of it. Another look at the same data, but the lightning aspect, there's a lot of lightning in some of the convection, which shows we're getting deep towers out over the tropics there, and it's moving over progressively warmer water. And I didn't have a lot of time to look at this, but looking at the just one snapshot of what I was looking at, the current situation is over the area of convection, there's light winds, even some hint of some relatively decent outflow to the north and south. And it's embedded in a fairly substantial west-northwest steering current. This trough on the East Coast, there's a shortwave exiting it, but the trough itself will maintain. And then the big debate is, depending on how it forms, whether it trots up into the trough on the East Coast, either as just the moisture or actually a developing storm, or whether it stays weak and undeveloped and meanders into the Gulf of Mexico, at which point all my neighbors get interested. The ensemble runs from last night, continuing the trend, the ECMWF has been more robust about forming a low and then running it up the East Coast. And it's tightened up. The spread isn't anywhere near as wide as it was yesterday at this time, with most of the members showing at best a weak tropical storm going through the Bahamas and up the East Coast of Florida, and then maybe attaining hurricane status as it stays out the shore just off the East Coast of the U.S. Let's see, what else did I have on that? Okay. Yes, our friend Michael Lowry puts this in his discussions now every morning, and I'll just shamelessly plagiarize from it, but this is the probability product for development of a tropical depression in the 3 to 5 day window in the Bahamas, and it fits within the probabilities the Hurricane Center has posted on this. The GFS, on the other hand, is still reluctant to do anything with this. It wobbles around with what few members develop anything as a depression or maybe weak tropical storm in the Gulf, but further west before it happens in there. and that's way down the road. I wouldn't put a whole lot of credence at that at this time. Let's see, what else do I got? Oh yeah, for those that follow the Eastern Pacific, make sure they haven't named this thing yet. Yeah, we're starting a depression. So now we have a storm in the Eastern Pacific. It's expected to reach hurricane strength during the week, and then the next one down is get that up here for you. See it. The next one behind it, coming off of Central America, is also given a high chance of forming as we go forward. Let me go back and get the actual forecast on it there. This very classic flow pattern of steering is dominated by a big high pressure to the north of the tropics there in the Eastern Pacific, and like most storms do out there, except last year where we had so many come into Mexico, but it's forecast to continue moving steadily westward, reach hurricane status over the weekend, and then hit colder water and drier air as it goes further west. And quick look at the satellite. This is our tropical depression that is forecast to fairly soon become a tropical storm, and the next system coming up behind it. That's what I got for now, Hal. What do we got next? I don't have the agenda in front of me.
Thanks, Bill. Alex, would you be able to share a little bit about our sponsors? We have fantastic sponsors that keep NTWC Plus going every week. Could you share a little bit about who our sponsors are?
Oh, absolutely. We have some great sponsors out there. USAA is one of our sponsors, has been really keeping us going for the last several years. We really enjoy their help to keep things going even during the pandemic. South Padre Island Convention and Tourist Bureaus. Wow, they have really helped us since the very beginning. The Weather Company came on board. They've also been with us, Weather Boy. And when you come to the conference, you get a special Weather Boy cookie. You can't get it anywhere else except at the conference. Then, of course, Weather Call. We have a brand new one here that has just come on board. The folks over at Weather Call, really great, and they've been helping us out quite a bit. And don't forget, if you missed the live cast here, you can always pick it up on our podcast, which is Hurricane Center Podcast, available on your favorite podcast app. Hal?
Thank you so much, Alex. Really appreciate that. Well, y'all stay tuned for the second half of the show today. We have a very special guest, Harry Emanuel, atmospheric science professor at MIT. But before we get to that, we're going to share a little update here from the GeoTrek project. GeoTrek's been traveling the world, telling stories about natural disasters and extreme weather, not covered by the mainstream media. And it was a big week this week at GeoTrek. We aired our 100th podcast. That's right, podcast number 100, looking back at historic Hurricane Beryl with special guests Phil Klotzbach and Brian McNulty. You know, some of the things that came out of that podcast, Brian and Phil both shared that Beryl would have been an exceptional hurricane had it hit in early September there in the east of the Caribbean. But the fact that it formed in late June and early July was absolutely unprecedented. Phil had said that just seeing a big storm early in the season doesn't necessarily mean you're going to have a hyperactive season. But the fact that this was coming out of the main development region with characteristics we would expect to see much later in the season. You don't expect to see a storm like that in late June and early July. He felt like this may be a harbinger of what's to come as we move into what's forecasted to be a very busy August and September. Also on that podcast, we got on the ground in coastal Texas to really interview storm survivors who survived Beryl. A few things that we really hit with that, having an early season hurricane like that, we're used to hurricane strikes in coastal Texas more in late August and September when it's still hot, but those sun angles are a little bit lower and it's a little bit cooler. Having a storm like that hit in early July, where 2.7 million people lost power, there were huge impacts as far as heat stress on people. Unfortunately, a lot of heat fatalities from people losing power during such a hot time of the year. A few other things that came in on that podcast was the concept of being prepared. You may have a generator in your garage, but you bought that 3 years ago and you haven't tested it yet. A lot of people were saying on the ground, I had supplies that were not tested. I needed a hose for my generator. I needed certain batteries for this device and just felt flat-footed. All these people we interviewed said they will be better prepared next time. And finally, the last thing that came out of this, really from a podcast recently with award-winning meteorologist Alan Seals from South Alabama, he had shared one of the first things you can do for hurricane preparedness is build community. And when he said that, I thought, okay, that's a feel-good message, kind of touchy-feely. Usually we think of hurricane preparedness, go down your checklist of supplies. He talked about the importance of building community. And in Hurricane Barrel, so many of the guests that came in our podcast talked about how they were able to help out other people in their neighborhood. Other people were helping them. Really, this concept that Alan Seals talked about, we saw on the ground how important that is. So if you want to be prepared for hurricanes, also build community in your neighborhood, know your neighbors. You may be able to help them. They may be able to help you if something does come your way this year. So that's the update from GeoTrek. And next, we're going to go into our second guest, Carrie Emanuel. Bill, would you like to introduce Carrie?
Sure. I don't have your bio in front of me, but I've known you for quite a while now, Carrie, and I've read a lot of your work. Carrie's been a substantially awarded meteorologist, professor in the atmospheric sciences at MIT. Where we've crossed paths is his work on tropical cyclones and the interest on intensity potentials, where we're going with it. Climate change came in later on there. Now, like me, Carrie, you're retired. Tell us a little bit about what you're doing.
Well, I'm having a ball. My retirement for me was rejecting things that I did not like doing, like going to faculty meetings, other committees, and getting back more full-time into research. So I'm very fortunate that I was able to retain that. MIT allows me to tap into their libraries and computers and other resources. So I'm having a really great time, Bill. I hope your retirement is, I'm sure it is, going as well as mine.
Yeah, I'm 12 years into it, believe it or not. And the load shedding I did was anything related to management. I don't even manage my dogs. But, so I find I enjoy that there's so much you can do with real-time weather just from your laptop and your easy chair at home that I really enjoy just doing the weather as just for my own interest, if nothing else. And it leads me down trails of learning stuff that I never would have paid much attention to in the past because I didn't have the time. I was too busy working on budgets and stuff. But yeah, so what persuaded you to become an advisory board member for Dan's company?
Well, I've been in touch with some of the people in that company for quite a long time, actually, and I've been very, very interested in the problem of operationally determining the intensity of hurricanes at sea. You know, the only time, I think you would agree with this statement, that we have a pretty good idea of how strong these storms are when we have an aircraft, reconnaissance aircraft, and they're making direct measurements and with a Doppler radar. And they're only flying operationally now over the Atlantic, and that's only 10% of the tropical cyclones on the planet. So, and that's not all the time either. I mean, the reconnaissance flights are maybe every 6 to 12 hours, something like that. So satellites have been really, really good at pinpointing the location of storms, particularly once they've developed an eye and you can really sort of see where it is. But they haven't been so great at figuring out how strong the storms are. And it's really, really important for forecasting and for getting people prepared for landfalls. And there are techniques that have been used for decades now to try to infer intensity. And they're useful, but there's still huge error bars on them. So my interest in the project that Dan's associated with is its potential to help us with that problem and in intensity. It's kind of interesting because one way you can do this is basically operates off of knowledge of how a hurricane works. And a hurricane is powered by sucking heat out of the ocean, quite literally. So as air spirals into the center, it acquires energy. It goes up the eye wall and out. And you can show in models and in theory that the wind speed is proportional to the difference in the energy content of the eye wall versus the distant environment. And then you can measure to a good approximation that if you know independently the temperature and the altitude of the cloud tops. And we know how to measure the temperature from infrared radiation, but that doesn't give us the altitude. And this project, for the first time, I'm pretty sure, because you're taking a stereographic view of the storm top, has the potential of getting the altitude down to maybe an accuracy of 100 meters or so. Wow. And at that level of accuracy, we ought to be able to take a pretty good shot. And when we try that by pretending that we're observing model hurricanes with satellites, it works pretty well. So I'm optimistic that for the first time, we're going to start to shrink those error bars, and that will help with the forecasting.
Excellent. Now, my conundrum when I was doing operations was they were both related, but it was two parts of the same problem. One was the genesis sequence, getting better at forecasting when the conditions would come together to where the storm would actually form, and then trying to find methodologies to better forecast rapid intensification. At the time I retired, we virtually had no skill. It was pretty much you'd catch a few of them on the front end as they were starting. You knew there was some pattern recognition with the development, and you'd go for it then, and you'd usually get that right. But anything beyond about 24 hours, we didn't have much in our toolkits. I see some improvement in the models, but I'm wondering if there's something observationally that'll help initialize those models.
Yeah, I mean, that's it. You can have a perfect model, but if you give it the wrong starting condition, because you haven't observed the system properly, you're going to get the wrong answer. Mm-hmm. And of course, needless to say, the models aren't perfect. So this project is about particularly getting the wind speeds of the storm much better with less error observationally.
Yeah, so from what I could read there, it would be a significant improvement over, say, what the non-recon basins derived from Dvorak techniques, for example.
Yeah, that's right. And I think it's important to remember that there are some very, very deadly hurricanes outside the Atlantic that affect most of Southeast Asia, India, Japan, the Philippines, and then down in Australia and over to Madagascar and Africa. I mean, these parts of the world have been hammered, and we're not observing them, these storms, with aircraft routinely anyway. And so forecasters there really need a big leg up. And even in the Atlantic, as I think you pointed out yourself, Bill, we're not flying all the time. So if there are rapid changes, we don't necessarily pick them up with the aircraft.
Yeah, the convention is we're not going to fly them when they're outside of 48 hours from landfall, partly because of you'd spend most of your time flying the airplane to and from the storm rather than gathering data. So the storms coming across from Africa are the ones that are recurving that might affect shipping lanes, Bermuda and Canada. We may all sigh relief here on the coast, but those folks, it's a serious issue for. And the remote sensing other than aircraft is very important for that.
Yeah, absolutely. And some of these storms, when they recurve, they become hybrid storms, or they undergo this sort of extratropical transition to become pretty strong non-hurricane storms. But to forecast those, you have to forecast the hurricane to begin with. And a lot of them, affect Europe. So what you just said resonates with me, because if you want to make a good medium or long-range forecast for Western Europe, at certain times of the year, you need to get this right as well.
Yeah, seem to remember a storm named Ophelia a while back that ravaged England, the British Isles, in its extratropical transition phase. It still had plenty of energy, courtesy of the tropical component.
Yeah, that's right. That's right. Yeah. And, even today, I've been working on a case, Bill, I think that would fascinate you. It began with my reading in the newspaper about a real tragedy. A couple had been sailing out of Halifax, Nova Scotia, just a few weeks ago, and they disappeared. And sadly, their bodies were found in a life raft that came ashore on Sable Island. I said, I wonder if the weather had anything to do with that. And I started to look at that. And I'm pretty sure that a unnamed but very definitely tropical storm formed in a remarkably short period over a northward bend in the Gulf Stream. I'll try to show you that sometime if you're interested. Just really fast. Didn't even last very long. And it was kind of in their sort of projected path of the sailboat they were on. So I wonder if it had anything to do with it. But regardless, it was meteorologically fascinating. and potentially very dangerous. So that's another case where having observations continuously in time might have helped us.
Yeah, and developing a good pool of data for the climatological aspects. I used to argue with guys at the Hurricane Center about the compartmentalizing. It's a tropical storm or it's extratropical, and never the twain shall meet. I think it's just like severe thunderstorms. It's part of a spectrum. There are all kinds of mix and match type hybrids that occur as these systems interact with different parts of the atmosphere.
Oh, yeah, I very definitely agree about that. I think you see a whole spectrum of storms that span between the pure tropical hurricane and the pure non-tropical winter storm phenomenon. Yeah, there's lots of things like that. Even polar lows are in that category.
Maybe a young new version of Akira Emanuel crack the code on some of that, working on a PhD someday.
Well, it may be happening as we speak. Who knows?
Yeah, that's true. The warming of the ocean and the Gulf Stream that you mentioned there, do you foresee that we'll start seeing more of these tropical to subtropical developments further north than historically?
Yeah, I think there's some evidence that we're seeing northward in the Atlantic and also in the North Pacific, a northward migration of the points where the tropical cyclones reach their peak intensity. And we think that's related to the global warming phenomenon. Even if you uniformly warm the world's oceans, for various interesting reasons, the warming has more of an effect on hurricane intensity sort of in the subtropics than it does in the deep tropics. And that's propelling, we think, a kind of a northward expansion. And then it has real consequences if it's true. You might see some relief from tropical cyclones a little bit in the extreme equatorial ranges of where they are today, and some worsening in places like where I'm speaking to you from, which is New England.
Yeah, it's not just the ocean either. I think there's some, if I recall reading, there's some of the changes, especially during the warm season, and the atmospheric flow contributes to that northward migration. Am I correct on that? Or?
Yeah, and one of the difficulties we have in trying to forecast how storms will respond to climate change, whether it's natural or man-made climate change, is that, it's tempting to simplify things, and you hear this all the time. Are there going to be more or fewer storms, or are they going to be more intense or less intense? But it's much more complicated than that, because you could have situations where you had more storms and they were more intense, but they all stayed out at sea, in which case the hazard would reduce, right? You wouldn't have landfalling storms. That's an extreme thing. We don't think that's going to happen. But the point is you need to take into account the tracks, the genesis points, all of that. That's a very big intellectual challenge to try to get that right.
Yeah, and I would just being having been burned so much on short-term modeling, I'm very skeptical of any skill at climate modeling of narrowing down who's more at risk in the future on tropical cyclones. I just don't think there's skill in doing that right now.
Yeah, so the way we kind of try to look at this now is a problem in risk assessment and management. And, not unlike what everybody does if they're, for example, going to buy a car or a house, what's the probability it's going to be in an accident or burn down if it's a house? What's it worth to me to try to buy some insurance, or to try to mitigate things like putting sprinklers in the building, something like that? And I think with the climate change, we look at it the same way. Do we know exactly what's going to happen in the future? Absolutely not. Of course we don't. But we can bound it. We can say, under the worst conditions, this might happen. Under the most benign conditions, that might happen. And yeah, it's a lot of uncertainty, but for certain, the risk will change. There's no doubt about that. And unfortunately, the weight of the evidence is that it will increase in most places, not all places. And so our job as scientists is to give that information with all the uncertainty to people who have to make decisions and let them have a go at it. But yeah, and try to work as scientists to reduce those uncertainties. But there will always be uncertainty in that.
Yeah, and we apparently don't want to learn from it. The uneven growth and population trending towards coastal areas at risk for tropical cyclones is one I followed forever. I mean, that's what got me into this business. My father was on jury duty whether wind or water did damage in the Ash Wednesday storm back when. And that's what I've learned as a junior high kid, that there's jobs drawing colored lines on maps, so to speak. But we're not changing that. I mean, you look at what Hurricane Beryl down here, most of the area did not experience any hurricane force winds except in brief gusts. Yet 2.7 million people were without power. It's been, what, 3 weeks now almost? There's still a pile of tree limbs out in front of my yard, and the city said it'll be another 3 to 4 weeks before we get to your neighborhood. You can't imagine what the same path with a large Category 4 might do. And since there's been 3 basically do that historically in this area, it's pretty good bet that it'll happen again someday. And I got more places than I know what to talk about.
we up in New England were shocked at what happened to you guys down there. And, you know, we had 2 storms in January that were arguably stronger than Beryl was. They weren't tropical cyclones, they were winter storms, and they did millions of dollars of damage. And we lost power too, but only for up to a day, not for a long time. Of course, we didn't have to deal with the heat, but a lot of people do rely on electricity for heat. So it was a problem, but to take so long to recover from a Cat 1 hurricane in a place which is known. I wanted to mention, if I may, Bill, speak to a point you made just at the beginning of your last remarks, which is the migration of people to dangerous areas. And you know, I'm very interested in that problem, and it's very clear to people who have looked at this that we have inadvertently, as a nation, been subsidizing this migration by having state insurance regulators artificially hold down rates in hurricane-prone places. They're not supposed to do that. They're supposed to ensure solvency of the companies. They're not supposed to be price fixing, but they've been doing that for decades. And federal flood insurance, until very recently, has been way too low. The premiums way too low. They don't reflect the risk. And so you're not letting insurance do the socially good thing of communicating to people, hey, this is a risky place. You ought to either think twice about moving here or build stronger. And we've defeated that. And that's a big reason for that. And that's, you know, that problem is huge. And of course, climate change could make that worse, but it's a huge problem all by itself.
Yeah, the human, I can give you an anecdote on this, a factoid really. The TWIA, Texas Windstorm Insurance, they're the state-run corporation that provides windstorm insurance for all the people that can't get it through a normal company. I happen to have a house that's built a little better than average, so I can still get it through my company. I think I'm paying for 300,000 or something and change. I'm paying close to $3,000 for windstorm, just the windstorm. The TWIA people are on the verge of insolvency after Beryl. They're not even close to actual. I've known this, just what you said, I've known this for decades. That's why I tried to stay away from it, that they don't, the constituents argue with the politicians, don't let these guys screw us out of our money for insurance, when you know they're not. They're trying to make sure it's sound. And Florida is really a basket case from what I understand on that. And we're heading that way, I'm afraid, because I don't see much support for dealing with it. On the flood side, well, I don't like the way the whole program works anyway, but the what's happening with the jack up in the rates is people are dropping it. There's less people have flood insurance today than they had before Harvey or after Harvey. It's dropped quite a bit. So, hey, we've set the table for the next big disaster here. if you want to do forensics and make a lot of money, just wait your turn. It's
Well,
terrible.
that exposes the other problems. I bet a lot of those people who aren't buying insurance are betting on the federal government bailing them out, quite literally, financially, and with buckets. But
Well, it doesn't really work. But what I hear from people I know who have done this is they kind of choose between paying the big bill or paying their house payment. They're not on the high, they're not on the strong end economically to begin with. Maybe fixed income or low middle class. They can't afford it. So now what do you do?
Well, there has been discussion about serious programs, either through private insurance or directly through the government, of basically subsidizing people like that to move, helping them move to a safer place where they could afford the insurance, especially after a big event. You know, one thing that doesn't make a lot of sense is you have a big event like Sandy was in New Jersey, for example, and then you just build things back the way they were before. That's what everybody wants to do. It's a natural impulse, but it's not good long-term planning.
That's what happened after Harvey. I mean, there may have been several thousand buyouts. Sounds like a lot. There was 120,000 flooded properties.
Yeah.
You know, you're chipping away at the tip of the iceberg.
Yeah, and setting yourself up for the next disaster, as you pointed out. You know, you talked about the power going out for a long time. I spend a lot of time in France, and even in small towns, they have buried the utilities. Even in Scandinavia, where you don't have any soil to speak of, it's bedrock, granite, they still manage to bury the lines. And the payback time for the utility is about 10 years. That is, after 10 years of not having to send out crews every time the wind blows, you basically earned your investment back. But 10 years is apparently too long in the United States now. They won't do that.
We have in-ground wiring, and anything new being built in Lake City is underground.
Good.
The failure occurs at the main power that delivers where it delivers to, if something knocks it offline.
Yeah.
I don't know. I'm not familiar with how utilities really work. I'm just familiar with the fact that it's never worked down here. I mean, I have an old slide I use in preparedness that explicitly said from the source was the power companies that it had each category storm and how long it would take to restore the electricity, and it's right within. It took 7 to 10 days, right within what they had stated years ago. So I don't think it was a surprise to the people that do this stuff. Just citizens didn't expect it.
Well, citizens have a right to demand better in this day and age.
Part of our problem here may have been that we were extremely wet. I mean, we were at 200% of normal for June up across the northern parts of Houston where it's heavily wooded. So big trees are coming down and they're taking out they talked about pruning the trees, but I think a lot of the big trees actually came down on them. So that it was, that's always going to happen with a hurricane. Your ground's going to get wet and the wind's still blowing and they're going to come down. Whereas your winter storms up there, hopefully you don't have leaves on the trees as wind catchers.
True, mostly. Yeah, but we can't have snow on the trees.
Yeah.
Wet snow. You don't have that problem.
Hey, Hal, I've been hogging all the time here. We're running out.
No, that's great. Jerry, I had a question for you for the students that watch NTWC Plus, the young professionals that may come to you and say, hey, you have this amazing career where you're a world expert in atmospheric physics for hurricanes and tropical weather. What advice would you have for them about emerging topics that they could study and pursue and actually have the biggest impact in their career? What are these big topics coming out, do you think, in the next, say, 5 to 10 years?
Well, that's a big topic, and I don't know where to begin. There are a lot of exciting things that you can do in atmospheric physics. And also, I would say, since we started off talking about technology in the realm of observational technology, we've been talking about satellites and all the great things they can do, but we also talked about manned reconnaissance aircraft. We've got drones now. And so far, we haven't really designed them to fly in or above hurricanes to take measurements. But I think we're at the point where that's feasible. And then we really can program them to follow hurricanes and track them. And so that's a place where people with a technological bent could productively help with the practical side and the research side of measuring storms. In atmospheric physics, there are so many different problems that I think are not very well solved. And Bill alluded to one of them, which is the genesis of tropical cyclones. We're only just beginning to understand how that happens. And we're still not very good at predicting that. So that's a great area of research. And I could go on and on. One of the problems we have with hurricanes is that they work by extracting heat from the ocean, and they're kept in check by the friction between the moving air and the surface. And yet, when you really are in a strong hurricane, the surface of the ocean is completely wild. I mean, you have the air, it's filled with sea spray, the ocean's filled with bubbles, so much so that it's actually hard and maybe even technically impossible to say where is the surface of the ocean. You just go kind of gradually from bubble-filled water to spray-filled air. And we have no idea how to calculate how heat is moving through that, or momentum on the frictional side. So this is really a problem in physics. How do we deal with that? How can we deal with this mixture of air and spray, and how much of the heat's being transported by the spray? That's just one of many, many problems that remain pretty much unsolved in this field.
Carrie, could you see in the future teams of drones getting in to better sense this? And hey, if you lose a drone to an extra high wave, oh well, it wasn't a loss of life, right? It was a piece of technology.
Well, we already have the one place where we are doing something new and very exciting is the sail drones. They're literally robotic sailboats. They're about the size of a model sailboat, but they're very hardened, and they've successfully been steered into the eye walls, the really violent parts of hurricanes. And they've made very interesting measurements and even videos that you can go online and watch. So that's great. That's a step forward in that. But I think we also need to measure things higher up in the atmosphere. Airplanes are wonderful, but we can't fly airplanes in the turbulent boundary layer up to maybe a mile above the surface. We learned the hard way that when you do that, the engines get salted up. There's so much salt in the air that they fail, and that's too dangerous, so we don't do that anymore. But as you point out, we can afford to lose a drone now and then. And so that's another aspect that's important to measure that drones could prove to be useful.
Sure. Thanks so much, Carrie. It looks like we got about a minute or two left in the program. Bill, any last questions you'd like to ask?
I was just going to add on to that. I think the air-sea interaction and the oceanography aspects of tropical weather in general is understudied and probably needs a lot more work. So people that find an interest in that, I know there's some underwater drone technology that would probably be very good at studying what the changes occur in the near surface waters as a hurricane goes over it that might improve how we model that sort of thing. So as always, it's great talking with you guys that are on the cutting edge of some of this stuff. Carrie and Dan, glad you were able to be with us this morning.
Yeah, thank you so much. It was great.
Alex, any last overviews as we wrap up today?
Well, I think the program was excellent. We had a good conversation there about all the technology that was going on. And then, of course, I really enjoyed Carrie's bringing up the topics of the physics that we need to really understand. That spray going from the water back on up, the transfer of heat, all of that really important, and we've got a lot of students that are really excited about atmospheric activity, and so we're going to steer them in that direction when we do see them. But I want to say thank you again to Carrie and to Dan for being with us, and of course also Bill and Hal here. Thanks for making a really great program today. It was excellent. Want to also thank our sponsors. That's USAA, South Padre Island Tourist and Development Corporation, the Weather Company, the Weather Boy, and Weather Call. And don't forget, you can always pick up this entire livecast on our podcast called Hurricane Center, and you can get that on your latest podcast app. Thanks for being with us today. We'll see you next week.